the quadratic formula and the discriminant. So this lesson is all about using probably most people's favorite way of solving a quadratic equation. That's using the quadratic formula. Now you guys probably all seen the quadratic formula from algebra 1. It's this thing, right? X equals negative b plus or minus b squared minus 4ac all over 2a. That whole thing. Now, let's talk about where it comes from, though. Because it's actually fairly obvious where it comes from. And that is, if we just look at a normal quadratic function right there, and we do what we did last lesson, which is complete the square, you're going to get the quadratic formula. And that's all this little part right here is to show you. Like, hey, right, remember how we did this? And you can't have a number in front, so you divide by that number, so divide everything by 2. Over here, they divide everything by a. And then we're like, okay, we want to get the x's by themselves, so we move over the 1/2. In this case, we move over that ugly fraction right there. And then we complete the square. We get the middle term divided by 2 and square it. And then this is them adding to both sides. And once you do that, this factors perfectly, right, every single time. And this side, you just have that. What they did from here to here was they did common denominator. And then how do you get rid of the square? You square root it, and you're left with this. And then you get this by itself. That's where quadratic formula comes from. It's just completing the square. That's all it is. So if you ever need to prove the quadratic formula, you just complete the square on the general equation. Anyway, since we have that, this is like the shortcut to completing the square, right? So it's like completing the square without going through all the work. That's the benefit of the quadratic formula. Again, another formula I will give you. I give you the formula, just I know how to use them. So I will give you that formula. Let's talk about how to use it. So how do we use the quadratic formula? Well, first you got to put it in standard form. So key thing to keep in mind with quadratic formula, you got to set it equal to 0 first. So you want to put it in standard form because you have ax plus bx plus c equals 0. Much like completing the square, since quadratic formula is just completing the square, it always works. And that's a benefit for quadratic formula. It always works. So there's only 2 methods that always work, and that's complete the square, quadratic formula. And for a lot of people, complete the square, quadratic formula is a little easier. So let's just do an example of how to use this thing. So I'll give this right here. Remember, quadratic formula is x equals negative b plus or minus b squared minus 4ac all over 2a. So just like before, step 1 is set equal to 0. So I get x squared plus 6x minus 16 equals 0. Now if we're going to use to complete the square, sorry, the quadratic formula, a is 1. Remember, a is a coefficient, not the thing. B is 6, and c is negative 16. And all we're going to do is plug into here, right? A is always the x squared term, b is always the linear term, c is always a constant term. So x equals negative 6 plus or minus 6 squared minus 4 times 1 times negative 16 all over 2 times 1. Now this is 36. 4 times 16 is 64, positive 64 because 2 negatives. So I get negative 6 plus or minus 100 over 2. It's negative 6 plus or minus 10 over 2. And we have 2 answers. We have x equals negative 6 plus 10 over 2, which is 4 over 2, which is just 2. And we got x equals negative 6 minus 10 over 2, which is negative 16 over 2, which is negative 8. So 2 and negative 8 is my answer. Right, so it's a little work, but it's always the same amount of work generally. It's just, set equal to 0, find my values, plug it in, I get my answer. Again, quadratic formula always works. It's not the fastest way though. If you notice this, the fastest way would have been just a factor. 2 things that multiply get 6, we have to get 8, or x minus 8, x plus 2 equals 0. Split it, x equals 8, and negative 2. Fastest way is always a factor, and you always go on a factor first if you can, because it's just so much faster, right? It just took me 2 seconds. This took me about a good 30 seconds. It's still not hard, it just takes a little longer than just factoring. So that's always the best way. If you have a choice, factor if you can. But when you can't factor, much like the one we're going to do right now, right, if I multiply these together, I get 3x squared. No combination of 3 gets me 5, so this is prime. The only way you can solve a problem like this is either by completing the square or using quadratic formula. Only way, right? Those are only 2 ways that always work. Complete the square, which a lot of people don't like to do, and that's supposed to be a square, and quadratic formula. Only ones that work all the time. They're not the fastest way, but they always work. So let's use a quadratic formula here. And this would be a good one to use a quadratic formula. I would not complete the square here, because if you try to do that, you gotta get x by itself, and it makes it just ugly. So let's quadratic formula real quick. So -5 plus or minus 5 squared minus 4 times a times c all over 2 times a. So I just like to simplify this first. This is 25 minus 12. I get -5 plus or minus radical 13 over 6. And that's it. I can't do anything there. That's just the way it is. Nothing to do. Next one. Another one that's prime. Right? Like if I multiply these together to see if I can factor first, I get 5x squared, and no combination of 5 give me 8. So it's prime. Can't factor it. So the only way to solve it is use a quadratic formula. A, B, C. Right? Again, I will give you the formula. You should really kind of know it by now, though. All over 2a. Okay, so x equals -8 plus or minus 8 squared minus 4 times -5 times -1 all over 2 times -5. So this is 64. So many negatives. -20, right? Because 4 times 5 is 20, but it's negative there. So I'm going to get -8 plus or minus radical 44 over -10. I could break down 44. That's the same thing as saying 4 times 11. Square root of 4 is 2, so this is -8 plus or minus 2 rad 11 over 10. -10. Now a couple of things I want to point out. So here, these do not reduce, right? Remember, they're not, like here, 8 and 10. I cannot just cancel these two out, right? If I gave you this, it does not do this. Remember, this is stuck. It's a plus. It's stuck. Only way to cancel stuff out is by factoring it. And I actually could factor this. These have a 2 in common. So I could get this. And now these reduce because they're being multiplied. So I get, my answer is going to be -4 plus or minus rad 11 over -5. All over -5, which would make it look like. That's the idea. So again, do not just cancel. Don't be lazy and cancel these out. It doesn't work that way. You have to be able to cancel all of them out. If you want, you can divide everything by 2. That works still. Again, I cannot stress enough. Do not do this thing. Oh, so disgusting. Anyway, so that's quadratic formula. Next up, let's talk about a special term, the discriminant. Now, discriminant has to do with the number of solutions. That's all it's about. So discriminant tells you how many solutions. Tells you about the solutions. So what's going on? The discriminant is the thing underneath the radical. So we know this is our quadratic formula, right? But if we only care about the stuff underneath the radical, that b squared minus 4ac, that tells us things. So really, we have 3 choices. The thing in there could be negative, right? Like, what if I gave something like that, and the inside thing is a negative? Well, what happens there is you get an imaginary number. Imaginary number means that you have, if it's negative, you have no real roots, right? It doesn't cross ever. So when that happens, you have no real roots, or also known as too complex. Right? So if the discriminant's negative, look what happens, right? If the discriminant's negative, I get an imaginary number, so I have no real roots. They're all imaginary roots. And what does that look like? That means you don't cross. Because remember, x-intercepts are real roots. So if you get a negative, that means you have no real roots, and that means you have no x-intercepts. So that's the first one it could be. Second, what if that thing's a 0? Right? What if the discriminant's a 0? So you get something like this. Well, this cancels out. You just get -3 over 2. You get one answer. Remember what happens when you get one answer? It's a double root. So if the discriminant equals 0, there's only one real root, which we call a double root. And finally, what if it's a normal one? What if we get 2 answers like we did here? What if it's a positive? Well, then we get 2 answers, plus and minus. So if it's positive, you get 2 answers. And that's what the discriminant tells you. Let me write it again a little nicer. So the discriminant which is this. Here's a we use a triangle to say it's a discriminant. That's the formula for it. Triangle is b squared minus 4ac, just the thing underneath the radical. And if that thing is positive, that means you have 2 real roots. If that thing equals 0, that means it cancels out, you only get 1 real root. And if that thing is negative, that means you can have a negative underneath the radical, so you have 0 real roots, or 2 imaginary. AKA 2 imaginary. So that's what discriminant is. This is a quick way of saying, hey, what type of roots do you have here? If you take the discriminant and it's positive, that means you have 2 real, because you're going to get a plus and minus. If you get 0, that means it's going to go away and you have 1 real root. If it's negative, that means you can have imaginary numbers. And that's kind of it. So let's do a couple of examples of the discriminant. And all I want to know is, what do we get for discriminant, and then how many real roots do we have? And again, I'll give you the formula for discriminant. Discriminant is this. B squared minus 4ac. You just got to know how to use it and what it means. It's like, okay, that's a discriminant. Let's find a discriminant for this thing. So this is A, this is B, this is C. If I'm doing a discriminant, I'm going to get 8 minus 4 times 3 times 2. This is 64 minus 24. So I get 40. Right, so discriminant's 40. What does that mean? It's positive. That's all I care about. It's positive, so I have 2 real roots. That's all that matters. It's a positive value. So let's do the next one. A, B, C. So discriminant b squared minus 4ac. I get negative 6 squared minus 4 times 2 times 9. 36. Now look what happens here. Negative 8, 72. 36 minus 8, I get negative 36. So this is, again, all I really care about is it's a negative. If it's a negative, I'm going to have imaginary numbers. So this is 0 real roots. Or 2 imaginary if you want to say it. So 0 real roots. Last one you probably could guess. This is A, B, C. 8 squared minus 4 times negative 16 times negative 1. I get 64 minus 64, which is 0, which means I have 1 real root. So it's a little tricky, right? My answer is 0. That means if you're doing the formula, that's a 0. So you're going to get 1 answer. So 0 is 1 real root. Negative is 0 real root. So that's the only part that's a little tricky. But that's this lesson.